Hi, I'm Sai from Team iCite, a team of machine learning researchers from around the world. iCite, an LLM RAG-powered research engine to revolutionize the way ML research is conducted throughout the world. ML researchers are pioneering life-changing technology, and more focus and funding is being put into AI and ML than ever before. However, this brings about two major problems. One, so many people are trying so many things in ML and publishing so many papers that it's hard to understand that if my new idea as researcher is actually new and original. So two, when I go search for existing papers to see if my idea is actually original, because there's so much hype out there, relevant research to me is hidden behind lots of irrelevant results that might be recommended to me by current research database search engines like Google Scholar from their search algorithm based on keyword search and how many papers cite a certain paper. So, to make research more efficient and easier with our AI powered search engine, we have scraped over 20,000 research papers from databases like Archive and Semantic Scholar and developed a page rank algorithm built in MATLAB that both filters out papers that are not academically reputable or cited at all, and two, ranks them based on their importance, which is determined not only by how well cited a paper is, but also how well those citing papers are cited themselves. We used this ranked database to create a RAG pipeline that informs a cloud LLM, which generates the most useful information regarding a user query, summarizing current research on a subject that may be inputted, and providing exact citations to specific papers that can be cited in a research paper that the user might choose to write. With that introduction, let's go into the product itself. This is the iCite application, and it offers three primary features: LLM query search, graph-based search, and smart database search. We can begin by looking into the query backed by the Cloud LLM. Here, the user can input any query they have on a certain research subject. For example, what is the current state of research? I will put machine learning research with regards ML applications for teacher student learning relationships. And now this LLM will use our RAG pipeline to search through the database we created by scraping 20,000 plus research papers and matching our user queries embedding to the vector embeddings of the many research papers that we have compiled. And going through those papers, it'll generate a response which will A, summarize the current research around teacher-student learning relationships and give me direct citations that I could use and refer to when creating a paper of my own. So here we go. It has given me the current state of machine learning search with regards to ML applications, and it gives me this current state and says several student recent studies have explored using ML techniques to optimize the teacher-student learning experience. And most importantly, it's given me these citations with direct DOI results for me to be able to go and search for these papers and read them more thoroughly. And so this is a great way for a researcher who has an idea in this space, let's say teacher-student learning relationships, to see what's going on right now rather than going to Google database and literally put in the query and just get a huge list of papers that are dense and you have to go through every and single one of them to actually get an idea of what the current research is. Rather, using the power of LLM and of the cloud LLM and augmenting our results with the research database that we compiled, we can create a much more useful response using the LLM. Now, let's say that the user actually knows their subject, they know what they want to do, but they actually just want to see papers. They don't want a summarized response. They just want to see pure papers like Google Scholar. Well, they can go to this text matching feature, which uses our PageRank algorithm. Here we can put in the exact words we want to see. For example, we want papers on natural language processing. And we can press search, and it will return, much like Google Scholar, a list of databases, so a list of research papers. However, this is far more useful than Google Scholar as we have gone through and developed an algorithm to only give us the most important papers, papers that have been cited greatly, and cited by papers that are themselves cited by many reputable sources. And these results are, we know for a fact, will be useful to us by the fact that not only have they been cited, but those papers that cite these papers have also been cited well. Finally, the user can go to a graph-based search, where after inputting a query, they can see the network of citations that have been generated from our query. So here are the various papers that were cited in the query from before, and we can see how these papers relate to each other citation-wise. And it's the way to visually understand what papers that I could be using when I create my own research study. Perhaps I'll cite this paper as it cites many other papers, or I may even cite this paper right here as it gets cited by quite a few papers. And the similarity will be seen through their distance as well. The vector embeddings also are compiled into this graph, so the closer two nodes are together, the more related those papers will be. And I can hover over these nodes to get more information regarding these papers and various other features that can be used to understand what are the papers that are going to be most useful to me and important in a research setting. And moreover, to the side, I can see the papers themselves, but I can directly click on and it'll take me to the article themselves. It's a very useful way to understand what papers are useful to me in this query that I have submitted. And that is iCite, a way to make getting into research and starting research efficient, faster, and much more useful. And that is iCite, providing a clearer vision for machine learning researchers around the world to empower the future. Thank you.